Hi and welcome to another exciting episode of the Astro 30's Electronics Lab. Before I get started today, I think I might go take a crap. Greetings, the Astro 30 here yet again, and welcome to another episode. This is part 10, I believe now, of this Classic D Class D amplifier build where I take John Clark's Classic D amplifier modules and build them into a case. Now, before we get started on today's topic, which I'm planning on doing the front panel. Now, I still don't have my knob, but I do have a knob which is roughly the same height and same diameter, which is on the other amplifier. It's just a aluminium one, a bare aluminium one. It's not a anodized black one or anything, the one I ordered, but it'd be the same depth, so at least I can work out with the front panel on how much of this control I need to take off, if any. But before I get to that, I have noticed that when I burnt another CD using the YouTube library, I downloaded some, I want to say brand new tracks by an artist of the name of Drew Banger. Now most of them are R&B tracks. Okay, fair enough. I downloaded the 10 that were new, burnt them to a disc, played them through the amplifier, and all but one of them had distortion in the bass frequencies, which is kind of interesting because I don't remember the CD player ever distorting like that. The laser could be wearing out, and I have known them to cause distortion when they're starting to wear out, but it just leads me to believe that maybe I have a slight distortion issue on the preamp ahead of the tone network. I don't know, so I'm going to investigate that first, just to mainly purely clear my own insanity, or I should say cure my sanity, or is it help with my insanity, whatever. To put my mind at rest that it's not the preamp doing it, it's actually the input source, the CD player. I'm tending to lead towards the latter. It's the CD player that's actually doing it, not the amplifier. But I can verify that. But first, let's have a look at, for those of you who don't know, what distortion actually is or looks like. Someone was being rude last night, and it wasn't me. Well, actually, it must have been me because I was the only one here. Anyway, moving on. Need another pen. We're going to look at what it looks like on an oscilloscope. Now, we're going to use a sine wave for the demonstration here, and there's a microphone digging into my back here. So here is our oscilloscope, for want of a better term, screen. There's a 0 reference line. Now, normally a audio signal, in this case a sine wave, usually goes positive and goes negative back to the 0 point, crossing over the 0 point. Now, there's a couple, well actually a few types of different distortion. Take another colour. There is one known as this, so it goes. You got flat topping and flat bottoming at both at the same time. That's called asymmetrical clipping. That's where the sine wave or music source is actually clipping evenly both on the positive and the negative going cycles. And that's a rather harsh sounding distortion. And this is often used in electric guitars and stuff to give it a nice crunch sound, so that's actually intended. The second type of distortion is, I might have to redraw this. So there's our zero line. Our second type is, we've got our sine wave, but it does this. It either flat tops or it flat bottoms, but never at the same time. As this is known as flat topping, flat bottoming, and this is usually a good indication that there is a DC offset on the amplifier somewhere, which is causing one, or not usually both, but one of the half cycles to be clipped, and it can sound nasty, and it does result in the bottom end sounding very distorted where the rest of the frequencies sound okay. And finally, our final type of distortion, which is mainly common in power amplifiers, not so much preamplifiers. This, which is called crossover distortion, where there's a little few microseconds or whatever it is, dead time on the zero line before the negative cycle starts, between that and the positive half cycle, and that does actually sound nasty and sounds like crackling on the output, depending on how severe it is. Now, I know from what I can hear on the audio output that it's not crossover distortion. I can confirm it's coming from the preamplifier, not the power amplifiers, because I plugged it into the headphone sockets and the distortion is still there. So it's not crossover distortion because op-amps usually don't have crossover distortion. The only time you get crossover distortion is when you've got output devices that aren't correctly matched, which is why a lot of Class A, B amplifiers have bias adjustments on them for that reason, to shift this crossover point to minimize crossover distortion as much as possible. So I know it's not crossover distortion, and I don't want to spend all day pissing on about this and pissing about chasing a problem that may or may not actually exist. That is, in the actual unit, it's actually to do with the input source, not the amplifier. But just for my own sanity, I'm going to run a couple of quick tests. And yeah. Apart from farting, there is actually another type of distortion whilst I'm thinking of it, is harmonic distortion, where you have a third order or fifth order harmonic superimposed on the original waveform. But we won't get into that because it has absolutely nothing to do with the current distortion that I'm experiencing. So let me just get set up with an oscilloscope and the DDS, and I'll run a couple of quick tests on this and prove or disprove whether this actually does or does not have any distortion present on it. Alright, I've got everything set up, I've got the scope going, it's grounded. Amplifier's off, I've got the DDS over to the left, which you can't see. That's set to a base frequency of 60 Hz at 2 volt peak to peak, which is the worst case scenario of the output of a CD player. Now, I'm going to turn the amplifier on. I've got the volume down low. I've got it the DDS hooked up to an empty channel. So I'll just plug the amp in after throwing everything off the top of this bloody thing. Right, I can hear the output. Sounds alright to me. Alright, so I'm going to probe the output of the first preamp before the tone network, which is pin 1 of the first IC. And I can see right away that that is a reasonably good waveform. and it's pushing 4 volt out as expected. So let me just turn the time base down a bit. There we go. I can see that it is a perfectly flat, well, perfectly sinusoidal waveform. My volts per division may be a bit high, but and turning the bass up and down has no effect on the input preamp. Okay, so I'm going to change the frequency to 20 Hertz. Which is a good subsonic frequency. We can't actually hear it now, but that again is also perfect. Now that's at 2 volt peak to peak input, still getting 4 out, so the input preamplifier is not distorting. So can you see where this is going? As to how far it can go before it does distort, I'm going to change the amplitude to 3 volt and probe pin 7, and we've still got a good sine wave up to 6 volt out. So even if I increase the amplitude up to 4 volt, it's still a perfect sine wave. So I know, turn that off, there is nothing wrong with the preamp, or at least not the first gain stage. Now I noticed even turning the bass control down, I don't know if I mentioned it or not, the distortion was still there even though there was no bass response. So I'm pretty sure that it's actually coming from the CD player. I'm not going to piss about with this anymore and do any more tests. I've tested it as far as I want to test it. There's no distortion at the input over a given set of frequencies, 20, 60 and 100 Hertz, which is about average for bass frequencies including subsonic. So it's a perfect sine wave. I know the preamp is not distorting even at 4 volt peak to peak in. So it's definitely coming out of the analog circuits of the CD player. It must be the way that the tracks are compressed and maximized or limited to a certain degree, or they're not limited correctly. In other words, they're not engineered correctly. They're not mastered correctly. So they've been compressed way too hot and they've been maximized way too hot, and it just distorts the poor analog amplifier circuitry of the CD player. So anyway, I'm going to move on from that and move on to the next thing of this, which is going to be kind of important. Now the next thing I want to see is how well grounded these pots are to the actual metalwork, or I should say how good of a ground connection everything's got, because sometimes you touch the controls and you can inject noise. I can't do it now for some reason. It stopped doing it. But anyway, I've got all the accessories unplugged, like the sub, the input to the CD player, so there's no grounding on this amplifier at all. It's just as it is, and it's also unplugged. So what I'm going to do is I'm going to take my multimeter, and I'm going to touch the star earth point on the chassis, the rail, that's grounded. Pot is not. In fact, oh, that one is, and that one is. So the rest of this circuit up here, the tone amp and the volume control, would be getting probably a ground reference from these two pots here at the bottom. But that, and that are not grounded. That's interesting. Well, that pot is actually getting a ground to the rail. That one is not. That one is, sort of. Excuse my sniffing. So that one is, that one's sort of. That one's not. Okay, so what I plan to do is I'm going to make sure all those pots are grounding to the chassis correctly, so that when you touch them with your fingers they're not going to inject any hum or noise. Means pulling the boards back out again, but that's alright. I'm just going to file a little bit off the top of each of these pots, add some link wire across all the pots, and then another wire down to the ground point, just to ensure that the whole thing is grounded correctly. It doesn't affect the grounding of the actual circuitry, it just makes sure that the pots are correctly grounded. So that's what I'm going to be doing next. Alright, so I've already filed the tops of these pots. I'm going to have to take the other two boards out to do the same because I can't do it with it in the case because it's sinking the heat too much. So all I'm going to do is just tin the top of the pot where I filed, and then just let the heat go into it. Okay, this is what I meant. I've got a wire attached right down the centre of the control here, as far down as possible because don't forget there's a board sitting up against this, and then it's terminated at a little eyelet here, and the same is also true here. Got the controls all joined together via tinned wire going to a length of hookup wire to an eyelet, and the same is also true down here. There it is there. See, bar. I didn't actually have to take the board out in the end. I managed to get it to penetrate, and that goes to an eyelet also, and they will connect to here. So I'll do that now, hook that up, tip the case upside down to make sure there's no bits of dags of solder hanging around, and then we'll move on. Penis. Okay, it's now grounded, as messy as that looks, but it's functional. So now when I do my ground test, one end on the star earth, well, the shafts of the pot are earthing. Not so much the well, they are. Anyhow, we've got the pots are now earthed, so there should be very little noise injected now through the potentiometers. Now I need to tip the case upside down. Right, so hopefully I haven't created an earth loop or a short. I shouldn't have. So let's turn him on and just verify. Well, still a bit of noise being injected, but that shaft's not making electrical contact properly. Yeah, but there's no earth loops there, so that's fine. Okay, so moving on. Before I get too happy, I just want to make sure that the front panel fits on there correctly and all these knobs turn without interference. Get past that switch. Right. Yeah, it looks like that base pot has to be, the hole has to be reamed out. Mid-range is fine, treble is fine, volume is fine. Those two appear to be fine, so it's just this one pot here. Okay, I reckon that it probably might be a little bit easier to just change the alignment of the board by just bringing it up, yeah, just like that, and then tightening it. That means that one's probably out as well now. Yeah, alright. That's the problem with drilling holes that don't fit the components properly, like oversizing them. tend to move in the hole and not stay central. So now when I try this, oh, that's a lot better. Yeah. Okay, so everything else seems to fit okay. Brilliant. And before I get too involved, I'm just going to check how much shaft, if any, this control needs to be taken off. Now, the knob I've ordered is 22 millimeters, and this one is, yeah, the same 22 millimeters. So it's going to be the same depth of pot, and it's machined exactly the same way. It's just black. So if I put that on, that actually comes right up to the front panel. So if anything, when I put the knob on, it's going to have to come out from the panel a lot further. So that means the shaft of this is not quite long enough, but I don't have to modify it. Okay, with everything unplugged and out of the way, next thing to do would be to clean the front panel and probably close the iris a little, because it is a little bit, shall we say, bright. So I'll close the iris just a tad. There we go. And I want to get the fingerprints off before applying the Letraset ladling. So I'm going to wear some gloves. Now I don't have surgical gloves, they would be perfect in this instance, so I'm just going to use ordinary kitchen rubber gloves. Cheap's the same thing. And from now on, I'm not going to be handling the panel with my fingers. Now, I didn't do this with the rear panel, and I probably should have, because there are a couple of fingerprints on it, but, ooh, they're cold. This is the front panel, and it's what's going to be exposed to the rest of the world, to, you know, people looking at it, and the last thing you want is blotches in the final lacquer finish and fingerprints underneath it and all that sort of crap. Ooh, yeah, that's sexy as hell. It's now air drying, and then I'll hit it with a heat gun a little later. Just one thing, the volume notation went off to the right, and the way I fixed that was these rub-on lettering, this Letraset stuff, will come off with acetone. Just be aware that it is going to damage the anodization of the metal as well, so keep that in mind. But you know, I'm going to let that dry, and we'll come back when we're ready to fit it to the amplifier. I think it's time I take a break for about 20 minutes or so and maybe have a wank. No, I did that this morning. But no, it's looking very sexy, and I can't wait to get it on the case. But I'm going to have to. There's nothing worse than tacky varnish, lacquer, whatever you want to call it, and sticking a thumbprint in it. Because that'll stand out like dog's balls and be there forever. So I'm going to let that air dry for about 15-20 minutes, and then I'll hit it with a heat gun to finish it off. Okay, and welcome back to the desk, which has seen better days. That's the panel there. It's been heat dried as well with the heat gun. So first thing I'm going to do is apply the handles and do a test fit to the front of the case, because I want to make sure that these screws do not interfere with the sub-chassis screws behind it, because I reckon these holes are directly in line with it. I'm hoping they're not. So we'll open our little packet here of our nice sexy handles, which has never been opened yet. Now this is how I remember rat cases, not those crap plastic handles that you get in the J-car rat cases. These are the proper ones that they used to make, anodized aluminium handles. So I need a screwdriver and a screw. I'll try and avoid putting it face down if I can. So I will not do that. screwdriver. And it's alright, I didn't scratch it, so that's the main thing. This is awfully difficult doing it one-handed, but it is what it is. So started that one off. The very far edge here is still, top edge is still fairly tacky. Not really that tacky, but not completely dry either. Okay, so that's that one. Now this one. It's always a good idea to start screws like this first before tightening, so you don't put things into a bind or cross thread things, because that always makes for a bad day, especially when you start stripping out aluminium. And they've got quite a bit of a bend in them, so that should be tight enough for that one. I'll just do this one here. Bit of crap in there. Alright. Now I've got something to pick it up with. Alright, anyway, now to do a test fit onto the case. Because if this doesn't fit properly, these handles are coming back off. And, well, I can see immediately they do line up, okay. But, no, they don't interfere with each other, so that's brilliant. Yep, no, that's fine. So, yeah, it's starting to look like something other than just a box. Okay, so I'm going to take this back off because I need to put the power switch in first because it bolts up at the back of the front panel here, so that's the next thing I'm going to do. Okay, with everything in the way, as usual, just going to undo this. It would have been nice if they supplied a washer with this nut, but they didn't. Now, I didn't mark on the panel power, because I kind of thought it was obsolete or unnecessary, because it's pretty obvious as to what its function is. So, I thought I had a spanner that fitted this, but I don't, so I'm going to just have to tighten it as best as I can with a pair of pliers wherever they've buggered off to. Right there, whilst trying to get it as straight as possible. Looks pretty straight at the moment. So if I hold the edge of that, right, that's got it as tight as I can get it. It shouldn't rotate. If it does, well, yeah, well. Okay, so I need to remove this crappy piece of wire that I've got onto the LED here. I'm just making sure which one I've got the negative connected to, this one, so I know which end at this end plugs into the input selector board as to which is actually connected to negative. So I'm pretty sure it's, yeah, on the left hand side. So I can unsolder this. It's only just tacked on, and then I can solder on some proper wire and hook it up to another connector, brand new one, and get that ready and wire the mains wire in. So I've got a common up here and normally open there, so it'd be these two here, and that's normally closed. I believe that's what it says. Yeah. So this is when the switch is off, and this middle one is when the switch is on. So I need to wire it across these two. Okay, I just measured how long I need the wires. I was going to route them around the edge of the case with the mains wire, but then I thought against it. So I only need them about 600mm long. That should be plenty. Orange will be positive, white will be negative, or anode and cathode respectively. And I just need to find out what I did with my brown mains wire. Okay, found it. Needs to be roughly this long. And the other one the same length. And that's for the power side. And I've just lost my white wire somewhere. Where did you go, you little bastard? Onto the floor. Okay, now to strip back the wires and solder them. Now, I normally would pass the wire through the eyelet before soldering it, but it doesn't want to go through. It's a little bit thick, so I'll just do it this way. Is it the recommended way of doing it? Probably not. Does it matter? No, not really. As long as it's got a connection to where it needs to go, and it's a good, nice, solid connection, like so, it doesn't really matter. Now I've lost the other wire. There it is. And not that I need to do it, but I am going to put two small bits of heat shrink over these terminals. But there is going to be a larger piece of heat shrink on the outside, so it's not necessary, no. But it just makes it look more tidy, in my honest opinion. Plus I've got heaps of heat shrink, so I like using it. Not that that's any real excuse, but it's the excuse I'm sticking to. So there's that one as well. Right, now I need my heat gun, which is across the other side of the room. Okay. That's so much easier than using a lighter. You don't run the risk of burning anything either. Now, I'm going to move on to the whatchamacallits, the LED lighting. So orange was going to be the anode and white was going to be the cathode respectively. I'll also put heat shrink on these. Should I put a heat shrink on that terminal just in case? Yeah, why not? I've got the stuff, so I might as well do it. I mean, it is pretty pointless, but I don't know if it's even going to stay on there, to be honest. It might stay on there. Right, so this one I will pass through the eyelet and wrap it around the terminal. Well, as neatly as I can anyway. Okay, and then I can solder that on. Don't need to go overboard with that, just so it's actually joined, which it is. That's a heat shrink. Deal with that heat shrink in a minute. I think that's a good enough joint. Serve the purpose anyway. Another bit of heat shrink over that one. just make sure of my polarity here. That should be negative, which it is. Okay, so I'll put that heat shrink back on if I can. Thank you. Heat shrink that down. Oh, I even heat shrink the other one behind it, that's nice. Okay, so then I'm going to twist the wires together, trying to keep these low power wires as far away from the mains wire as possible, which is probably going to be next to impossible considering where they're located. I don't want to induce noise into the amplifier from the mains, if you get what I mean. So twisting wires like this on low powered stuff together does help combat induction, because the two conductors aren't running parallel to each other, so they can't induce in each other. Because they're wrapped around each other, it should technically, by rights, cancel each other out. Well, that's the theory. So now that that's twisted together, I can get a larger bit of heat shrink and put over the whole entire concoction. Over the whole entire switch. I know it's probably longer than necessary, but that's fine. This with a heat gun, which I didn't have when I was building either the other amplifier or the guitar amplifier. I didn't have this heat gun. It certainly makes a neater job of heat shrink. I don't know how far this will actually shrink down, but it looks like it's pretty far. So, got to let that cool because that's sticky, and then I'll tie a cable tie around the end of this. Alright, it's cold enough. Put a cable tie around it. Even though that's tight as anything, still going to do it. And I'm going to put a cable tie just around the end of this mains wire, but only, not with that. Keep that separate. And another one probably in the middle. And yeah, another one along there. Okay, trim that off. Now we're ready to fit it onto the penis, the front panel. Still haven't done the socket end yet, but I'll get to that a little later. Okay. So now we're ready to fit the panel to the frame for the last time, because it's going to get screwed on now once I get these wires to agree with me and go through the hole. Because as far as I know, this does not need to come back off for anything now, so I can go, oh there we go. Now hopefully that hole is big enough to pass the heat shrink through. Soon find out. Yep, it is. I was getting caught on an audio cable here. Alright, now find the screws for the panel. So all I have to do now is wire up the mains, wire up the socket for that, and that's going to route around through here, around these audio leads back up here, and it's probably a bit long, so I'll cut it down, and then up to there. So I'll be getting on with that, and we'll come back when I've achieved something. So positive goes in this one, and now it goes in this one. If they're wrong, it's easy enough to swap them around. But as I said before, I hate these connectors. I think I have. I've just said it again. I hate these connectors. Most of you will be asking a very valid question right about now. Well, if you hate those connectors so much, why do you keep using them? Well, because it's the only connectors with the locking tab on it that I can get in Australia without ordering those things from China. And I don't know what crimping tool suits that. I know I wouldn't be able to crimp it at home, so that's why I use these ones, because I can crimp it at home. And I'm sure there is a proper crimping tool for these style connectors too, but I can't find any information on one. If anyone knows of one, let me know in the comments below. So I'll just tie these up to the back panel so it stops these wires floating up in the air. And I'll put another cable tie around one of these. Yeah, this one will do, just to sort of like keep it neat. Trim these up. And there we go, that's basically the internal wiring all completed. Check it out. Got the mains wire in some eyelet self-adhesive things that stick to the side of the case. I didn't mention previously when I was doing the wiring before that I've also got some on this side to hold wires up the length of the case. Got one there as well, which is why I just put a cable tie through. But yeah, it's all complete. Wiring wise anyway, and front panel. So I guess the next thing to do would be to actually see if the power switch actually makes the thing work, or whether it kills the power switch. We'll soon find out. Alright, so I got the power lead connecting in the two speaker leads. I haven't hooked up the sub, I don't need it at this stage. I just want to turn it on and test that I haven't created any mains interference noise and injecting it somewhere into the circuit. So when I plug this in now, the thing should be completely dead. Which it is. Now if I hit the switch, bingo. Right. A little bit of noise there. Not bad. There is a yeah, right. Okay. Let me just terminate one of the inputs anyway. CD input will do for now. That's better. Yeah, it's not injecting noise now. Not sure how I go about fixing that, but it only seems to be when I touch the relays directly. If I was to touch the top of the case, yeah, there's some shielding issue there. That's alright. There is a pop when you turn the switch off. So a 250 volt suppression cap would have been good to put across that switch. I don't have one. I need something like a 0.033, somewhere in that realms, 250 volt AC, well X2 class type style capacitor, which would just go across the terminal block here. But okay, very, very good. Moving on, I can put my knobs that I've got on. So then sub gain. Don't have to be overly tight, just as long as they're on there. Okay. This one. Nice. Doesn't that look sexy? I think it does. Shame I haven't got me large knob yet, but yeah, so it's coming on. I don't know how long this video is going to turn out to be, but it is what it is. I'll try and keep it under an hour. If it ends up over an hour, it ends up over an hour. All those that actually like watching my shit probably won't give two hoots how long it is. Now, next thing to do would be to do the bottom cover and put the feet on it. So that can be screwed on, so that's finalised. Then I can put the top on, and that's basically calling the amplifier finished. But I might want to go out and get a X2 class suntan capacitor, just to put across that switch, so it's not arcing across the switch contacts. That's what it's doing, causing that pop when you turn it off. But yeah, unplug that. Unplug that because I need to move it all. Right. Yeah, so moving on to the back panel. I mean the bottom panel. Now with my penis, no, with this bottom cover, I was going to use these semi-professional looking feet on the other amplifier. I just never got around to attaching them. So I'm going to use them on this amplifier. I'll get them out of the bag. For anyone interested, there's the catalogue number there. It's HP0830 from JCar, and there is a larger size diameter of these two available. They're only just plastic. So I've just used the top area of the edge of the case here as a reference, and I need to clear for the screw 12mm from the edge. Now, which is not going to work right at the edge of the case here. So the next question is, do I put them in like that? And is that going to be a good way of doing it? Probably not. So what I might do is I might abandon this idea yet again. I'll go out to JCar because I want to get a capacitor, as I previously said. No, I'll just get one of those self-adhesive square feet. They're about 10mm high by 15 or 20mm wide, square I think it is. And I'll just stick them on. That way I don't have to drill anything. I think that'll be the easiest viable option there. So I'll go out and do that, and then we'll come back. Okay, and a short time later I'm back with some rubber feet. I think it's a pack of, don't know, 20? Doesn't actually say. Anyway, catalogue number there is HP0822. And I also got a couple of X2 class polypropylene 250 volt rated capacitors. One's a 22 nanofarad or 0.022, which should be alright. But I got a 100 nanofarad, a 0.1, just in case. We'll get to those later. First, I'm going to open this and take out 4 of these feet. Pretty sure I did actually buy some more some time ago, but I don't seem to have any, so it might be advisable for me to cut with scissors. Okay. No idea where I'm going to stick that there. Okay, so first off, I'm going to separate them into individual
chocolate bars. That's all they remind me of, Cadbury chocolate really. Right, and they're black, so they're going to match the panel. Just grab my glasses. 3M double-sided tape, how nice. So what I'm going to do is I'm going to stick them right close up into the corners, thereabouts. There's no screws or anything to worry about there. So I'll put this one right there. Tried to get it as straight as I could, but it doesn't often always work. As long as it is functional, right? It's really close to the edge though, that's the only difference, only thing. So I'll leave about a 10mm gap from the back. Yeah, where are you? Okay, and that's the feet on it, and that's now ready to put onto the amplifier. Alright, that's the bottom one. Now turn it over. Get it off course. And now it won't slide around the desk. Now as for this capacitor, I need to get it into that terminal block down there across the two switch connections. But first I'm going to put some heat shrink on the ends of these leads just to provide a little bit of insulation. In an ideal world it should really be wide across the switch, but I'm not pulling all the heat shrink off just to do that. And it is unplugged, so I need to plug it back in. If I can say plug it back in. There we go. Yeah, well, now that's defeating the switch. Yep, so that's not going to work. Okay, I think it's supposed to be across both the active and neutral. On the other side of the switch, not across the power supply coming in, but through the switch. So I've just got the capacitor touching those screws. Hopefully, it's a very dangerous thing to do. Don't do it. But make sure that's turned off. Yes, it is. And it's still not switching. Okay, I've done something wrong here. I've obviously defeated the switch somewhere. Lol. There's one side of the switch coming into the terminal. There's the fucking other side. It's going into the same fucking one. It's supposed to be, these two are supposed to be swapped around. Okay, so that means I've got to put that capacitor back in and do the test all over again. Okay, let's try that again. I've now got the switch going into the transformer and then the AC going into the other side of the switch, not having both ends of the switch joined together. Capacitor's back in. It's not tight for some reason. Okay. It just did not want to go in properly, did you? Okay. So I'll pull that wire back out and fuck around. I don't even know if that actually went in the terminal or under it, because that side's in, but this side may not be, so I'll just make sure I've lifted it up enough. I know I'm mumbling, but I tend to do that quite a lot. It should be in the terminal block. It's always good to pull on things after you've screwed them down to make sure, like wires, to make sure that you've got them in there tight. Yeah, now it is. Right, there's nothing worse than something floating around loose that's actually live. Now, plug it back in, the thing should now be dead. Make sure the switch is off, yes it is. Now it's dead. Now it's alive. Right, anyway, okay. Apart from my mental fuck up, turn the tape off. I'm going to wait a few seconds, I don't know how long. I can turn that off now too. I'll turn the volume up just a bit, just so it can
give it the best possible chance to produce any pop from the action of the switch. It shouldn't. And it doesn't. Right, that solved that problem. That will now remove any spikes from the action of the switch and possibly filter any coming in off the line. Well, it's not going across the active and neutral, so it'll only filter it on the AC side. But the point is, it's removing any arcing that this switch is doing. So now I can unplug it and put the top cover on. Okay, top cover time. Hope I've given that enough clearance. See if I now. Check it out. It's an amplifier. Oh, sexy. Yeah. Well, I'm quite pleased with how it's turned out, apart from the noise it's picking up from the input selector when there's nothing terminated to an input. Not much I can really do about that. I did screw around and try and ground the signal to ground. It made no difference. But it looks sexy as hell, and I've called it Classic D along with the power amplifier modules that it's named after. Class D 2.1 amplifier. And I'm really thankful for all of you putting up with the hours and hours of footage of me screwing around, fucking things up and then fixing them. And now we have a completed project, and that's now another major project out of the way, and it's going to be my last major project, I think, on this channel. Now, how much did this entire thing cost me? Well, I did a rough calculation, and I estimated it at $679. That's not including wasting PCB material remaking circuit boards. So we'll say a good 700 bucks. The case was 136. In fact, I think I've still got the invoice for that. Right, the case was $135.45. The 16mm knobs, I got 6 of them. They're $2.60 each, and yeah, $16 for that. The other knob, which was 28 odd bucks. No, sorry, that's the transformer, $4. Didn't use it. The small 30 V8 toroidal was 28. The larger 35035 was 79. So it's actually cheaper than the one I got for the other amplifier. That cost me $99. This one only cost me $79. The freight was $13 and insurance was like $2. So yeah, that all came out to a grand total with a GST amount added of $27. So the figures above would be GST free. So you got to add GST to all that. But yeah, $306 was the total for that, just for the case and knobs and transformers. The amplifier kits are about $90 each. And there's 2 of them, so that's $180. The power supply was about $50, I think it was. Can't remember off the top of my head. Speaker protector module was like $20, and yeah, miscellaneous other components will say about $100 worth. That's including resistors, capacitors, and diodes and other shit that I bought over the years and used, and also others I had to go and buy. And I've got the farts real bad, but you can't hear them. They're silent but deadly, and they stink. Just putting that out there. So yeah, I'm pretty much going to end this video here. We are going to do a final sound test on this before we go, just because I can. It's a shame I don't have my knob. I still feel naked without my knob. Oh, fuck, that stunk. Jesus Christ. Yeah, so as I said, I'm not going to make a video of drilling out the knob to fit the shaft and then put the knob on and then do the grub screw up. I mean, it's 20 seconds of video, what's the point? So we can imagine there's a knob the same size as the silver one on the other amplifier, which is, I think that one's 40, this one I've got 38. It's only slightly smaller in diameter. And the same height, 22mm. And it's just basically drill out the hole, put it in, and then do up the screw. I mean, if I don't drill the shaft hole out from 6mm to 6.5 all the way down to where it bottoms out, it may make it sit up on this knob, this control shaft a little bit further out, so I don't have to sit there and manually put it in position as to where it has, so it's not scraping. But yeah, whatever. Okay, so I'll just set things up to where I think they need to be. Make sure that that's set to CD, which it is. Right, let's do that sound test. Anyway, I'm the Astro 30, and I hope you enjoyed this video, and if you did, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, happy Class D amplifier. And by the way, Class D does not mean digital. Class D means switching. Digital and switching are two different things. Just putting that out there. Okay, it took me a little bit of a while to set this up because I was screwing around looking for a audio lead which goes from the 3.5 jack to RCA. I've done that now. Couldn't remember what I did with it, but I found it. Now, turn this on. Right, and now we'll play some audio. I'm on the right channel, which is video. So I'll just go in, open a track I know I'm not going to get hit for copyright. God, that's basic. Cheers. Yeah, I know that was kind of repetitive, but it was the only track that I made that I know has got quite a lot of sub-bass content to it. Anyway, thank you for watching. See you later.